Okay, so before we start with the notes, why, yes, I did.
I hope that you're still in, the kids come on in.
Okay, so before I start the notes, if you failed first semester CK12, that is due March 11th, which is a Thursday before we leave for spring break. I need that CK12 done by then. The other thing that still needs to be done for some of you is TELPAS writing. If you have not completed your TELPAS writing, I need that done ASAP. I've already printed out the ones that have been submitted. There's a few of you that did not follow directions and you did not do the lines I told you to do. It has to be at least 13 lines. So this is an example of what is acceptable, right? Like it's just a paragraph, okay? Like just like a good paragraph. For the most part, y'all did that. As long as you have like a good paragraph, when I print them out, you're pretty good. Something that is not acceptable would be, I'm gonna cover the name because would be this, right? Like how is in the world is that that's a 0. Like really? Okay, like y'all can see there's nothing there. Okay, like how in the world is that acceptable to y'all? I do not understand. This, I went on ahead and I told you to do it again. Okay, so you need to go back on there and submit it again. You know if you did what you were supposed to or not. Obviously, if you wrote a nice, good, decent paragraph, then we're good. Those of you that did not, go do it again. Okay, I have to print these out and go submit them. So if you still have not done that, I need that done by today, tomorrow. So that's TELPAS. Grade book. Okay, because of that whole winter storm, right? Like I've been behind on grading. You know, they gave y'all an extension for the 4-6 weeks. Okay, so for the 5th 6 weeks, I've already put in the gradebook lesson 6-1, 6-2, 6-3, 6-4 quizzes. Okay, today we're doing 6-5. Notebook checks, that's what I'm working on right now. So I've graded 6-1, 6-2. I'm in the middle of 6-3, but I haven't put it in the grade book. Okay. So if you haven't submitted those, I need you to submit them like quickly because once I put them in the grade book, that's when I'm going to start taking off the points. Okay. So as of right now, I'm not taking off any points for submitting your notebook in late for 6-1, 6-2, 6-3, 6-4. So even if it said late in Canvas, I still gave you full credit just because it's the first time that I'm putting it in the grade book. And when it's the first time that I'm putting it in the grade book, I'm not as picky, right? Once I've put it in the grade book, then yeah, that's when I'm just like, nope, I'm taking off 20% because you were late. It keeps closing on me, sorry. Okay, so that's great. So, if you have a missing in the gradebook for a notebook check and you're like, I submitted that, why? If there's a missing, that means I've already graded it. And if it was missing, it's one of two things. You didn't do it right, so I didn't give you credit, or you just have it missing, right? So if you know you turned it in, you need to go in Canvas and check if I left you a comment. Because if something was wrong, I'm telling you what's wrong so that you can fix it and resubmit it. Okay. Besides that, do I have any questions about grades or anything like that before we start our notes? No, we're good. We all understand what's expected and what's coming and everything. Okay, cool. Oh yeah, exam 6A. There's several of you that still haven't taken exam 6A. Y'all need to take that because exam 6B is coming. All right. And whenever we get done with the notes, I'll probably keep grading. But expect your notebook checks to be updated by this weekend. I think that should be enough time for me to get that updated. All right. So hurry up and get those pictures submitted because as of right now, I'm not taking points off. Okay. The moment I put them in, that's when I'm going to start taking points away. All right. So let's go ahead and get our notes started. Okay, so today's lesson is function operations, okay, which basically means this little chart that you see right here, okay, adding, subtracting, multiplying, and dividing functions, okay. So pretty much I'm giving you two different things, and you're gonna multiply them, add them, subtract them, or divide them. It doesn't matter what I give you. It can be any two functions, any two equations, or whatever. And just looking at what you see is what you're going to do, right? So it's kind of a little bit self-explanatory. So obviously, if you have addition, you're going to add, right? Hold on, wrong one. Why does it keep doing that? Draw. Sorry. There we go. So obviously, if you have a plus sign, and you see how we have f plus g of x, that really means you're going to grab f of x and then you're going to add g of x. So an example of that, I just gave you something easy so you can see the idea, right? So we're making f of x be 5x and we're making g of x be x plus 2. So because it says f plus g, that just means that I'm going to put a plus sign in between them and then I'm going to simplify. So that's really all you're doing. You're going to apply the operation that's given and then you simplify. So if I have 5x plus x plus 2, well, I have 5 and 1, so that's 6x, and then you have plus 2. Ta-da, you're done. Okay, and it's a similar for subtraction, right? So instead of a plus, you'll see that I have a subtraction sign. So 5 minus 1 is 4, and then you have this negative distributed, right? So you have 5x minus x minus 2. So 5 minus 1 is 4, and then that negative made that positive 2 into a negative 2, which is where your minus 2 comes from. And we're going to have examples, okay? So right now I'm just kind of explaining it out loud. Multiplication, obviously that just means distribution. So 5x times x is 5x squared. 5x times 2 is 10x, so you end up with 5x squared plus 10x, okay? And then division, same thing. But for this one, because we have a 5x at top and in the denominator we have x plus 2, that cannot be simplified any further, so that would just be your answer, you're done. Okay, so for example 1, so let f of x equals 3x, 3 times the square root of x. So we're going to have f of x as this, and then we're going to have g of x as negative 10 square root of x. So it's asking us to find f plus g of x, right? So what does that mean? I see a plus sign. So all that means is that I'm going to grab f of x and I'm going to add g of x and I'm going to simplify. That's all that means. So this right here is equivalent to f of x plus g of x, right? Which you should have seen that format before. I've tried introducing it to you here and there, right? Okay, so we're going to grab our f of x, which is 3 square root of x, and we're going to do the operator, which is a plus, and then we're going to grab g of x, which is negative 10 square root of x. So this is radicals, right? And we know that we can add and subtract radicals when the radical and the radicand are the same. So because these that I'm highlighting right now, because those are the same, I know I can basically combine them, right? So 3 plus negative 10 would be negative 7 square root of x. So this would be what happens when you add the functions f of x and g of x. This is what you end up with. Now, we're not done. It's also asking us to evaluate the sum when x equals 4. So all we have to do is substitute x with 4. So we're going to have negative 7 square root of 4. And all you do is simplify. We know the square root of 4 is 2, so we have negative 7 times 2. So what's negative 7 times 2? Negative 14. Ta-da! So these would be your two answers. So f plus g of x is equal to negative 7 square root of x. And f plus g at 4 is negative 14. So these are the two things we just found. Notice that in the first line, I have an X, right? So I was writing it in terms of X. And in the second line, that's when I specified. X is 4, right? So instead of writing X equals 4, I was able to replace the X with 4, and that tells you you're going to substitute 4 in. Okay. Example 2. Same thing. Let f of x equals 3x cubed minus 2x plus 5. And g of x equals x cubed minus 3x squared plus 4x minus 2. Find, so we're going to find, where's my purple? F minus g of x, right? So what operator am I going to apply? So what am I doing to both of these functions? What am I going to do with them? Exactly, right? So it's not that bad. It looks a little weird, but once you understand what's going on here, it's not that bad, right? So I'm just going to subtract. And then later on, I'm going to evaluate, but we're going to do that after we're done with the first part. Okay, so this part right here is the same as saying f of x minus g of x, right? Those mean the same thing. That's basically what this is saying. So I'm going to grab my f of x, which is 3x cubed minus 2x plus 5. And then we're going to subtract, right? We're going to subtract g of x, which is x cubed minus 3x squared plus 4x minus 2. So from here, you're just simplifying, right? And you know how to do this part, or we should. So from here, we should hopefully know that this right here is really a -1. So I'm going to have to distribute this -1 to everything on the inside, right? So we're going to end up with 3x cubed minus 2x plus 5. This -1 is changing everything on the inside. So it's going to be a negative x cubed plus 3x squared minus 4x plus 2. What would I do here? This is not the new part. You should know what to do here. What would I do now? Exactly. So all I'm going to do is combine like terms, right? So really the only new thing in today's lesson is the way it's given to you, right? So that f plus g, f minus g of x, that stuff right there, right? So the chart at the top. Everything else is pretty much what we've already been doing. It's just normal basic algebra 1. Bless you. So from here, all we have to do is combine like terms. So 3x cubed negative 1x cubed. That's going to give me 2x cubed. Then we have negative 2x, and we have this negative 4x, so negative 6x. Then we have a plus 5 and a plus 2. Bless you, that's a plus 7. And you can see that we have this right here left over, right? So that was a, what is it, a plus 3x squared. Now remember, I wanted in descending order, right? So I wanted in proper order. So that means my final answer is going to be, oops, this is going to be 2x cubed plus 3x squared minus 6x plus 7. This is going to be what happens when I subtract the functions f of x and g of x. Okay, now we weren't done, right? Then it's saying evaluate the difference when x equals 2. So what we're finding for, or what we're looking for, I'm sorry, what we're looking for is f minus g when x equals 2. So instead of x, I can put a 2 there, right? So that means I already know what f minus g is, right? That's what I just found. So all I have to do is subtract in 2 for x. So we're going to have 2 times 2 to the power of 3 plus 3 times 2 squared minus 6 times 2 plus 7. And we're going to just simplify. So 2 to the power of 3, that's 8. 8 times 2 is 16 plus Hold on, I'm making sure I did this right. Okay. 16. Wait, why is, oh, that was supposed to be a -2. Okay, no wonder. This right here was x equals -2. My bad, so let's fix that. Negative, negative, negative. There we go. So then this should be a -16. Then -2 squared is 4. 3 times 4 is 12. -6 times -2 is a +12, and then plus 7. So -16 plus 12 is -4 plus 12 plus 7. You're going to end up with 15. So your answer would be 15. When you subtract these functions, there it goes. So f minus g of 2 is 15. And when you actually subtract them, right, you get that. Oh, wait, why is this here? There we go. So for example 3, same thing, right? So I'm giving you an example of each one. So we've done addition, we've done subtraction. Now we're going to do multiplication. So let f of x equals 3x squared. So we have f of x equals 3x squared, and we're going to have g of x equals square root of x. So then now I want you to find fg of x. So fg means I'm multiplying, right? Because they're right next to each other. And evaluate the product. So this means that I'm going to have f of x times g of x. That's what that means, right? So f of x is 3x squared, and I'm going to put parentheses around it. And then my g of x is square root of x. Now, I have exponents, right? So I'm going to convert the radical into an exponent. So this is really just going to be 3x squared times x to the power of 1/2, right? Square root means 1/2 power. So because these are like terms, right? We have multiple bases. I'm going to use product law. What is product law? That means that I'm going to add exponents in case y'all forgot. So we know that 3 times 1 is just 3. So I need to add my powers, right, of 2 plus 1 over 2. So in order to add fractions, they have to have the same denominator. So this is really going to be 4 over 2 plus 1 over 2. 4 divided by 2 is just 2, right? So all I did was change the way it looked, but I didn't change the value of it. 4 plus 1 is 5 over 2. So my new power is going to be x to the power of 5 over 2. Now, there's several ways this can look, right? This, you could leave it like this, 3 times x to the power of 5 over 2, or you can convert it to a radical. So you would have 3 square root of x to the power of 5, right? Or you could even simplify that a little further, right? X to the power of 5, we know that's really 5 x's, 3, 4, 5. And I want groups of 2 because it's square root, which means I could take 2 of them out, right? So I could have 3x squared because I would have 2 groups of x's, and then square root of 1x because that's what got left on the inside, right? And I'm just showing you that you have multiple, I guess multiple correct answers, right? But they all mean the same thing. So it's just, so like if this were an SAT question, you just want to look at your answer choices and kind of get an idea of where it's going, right? But you always have to be able to keep simplifying. All right. I mean, yeah. Okay. So any one of those would be right. Okay. It just depends what your multiple choice looks like and what your teacher expects from you. Now, we're going to find what this is when x equals 9, right? So what we're looking for right now at this moment is I want f times g, but when x is 9, what does that equal? Well, we know what f times g is, right? You can use whichever one you want. I'm going to use the most simplified one, which is 3x squared square root of x, but you could use any one of them and get the same answer. Okay, so then that means that I'm going to substitute 3 times 9 squared square root of 9. Well, the square root of 9, we know what that is. It's 3, right? And 9 squared is 81. So we have 3 times 81 times 3. 81 times 3 times 3 ends up giving you 729. So that would be what you get when x is 9. And again, you could have used any one of these, right? You could have also used any one that I said was equivalent. All three of them should have given you the same answer of 729. I just chose the last one because I felt like it. Okay, I'll give you like 30 seconds to get caught up with that. Do we have any questions so far? I need y'all to type in the chat how we feel. So 1, you're completely lost. 3, you're okay. And 5, you got it. Go on ahead and type in the chat how we feel so far. 1, you're lost. 3, you're okay. 5, you got it. Like you feel super confident, like you'd be fine. Okay. All right. So for example 4,
Wow.
I guess it just depends. Okay, so I don't think. So what part confused y'all? Was it? I think the part that confused y'all was when we had to simplify, right? Am I right? So like you looking at this part in purple, right? You see how it has f times g of x. I don't think that's the confusing part, right? Y'all get that part, right? That you have to multiply the functions. I think what's throwing some of y'all off is like once you multiply the functions, the way you simplify them. Am I correct in that part? Is that the part that's more confusing? Am I right? Because that's what I'm feeling right now. Okay. Yeah, that part is just, you're just. So something I always tell my Algebra 1 kids is that literally Algebra 1 is the most important math class. Why? Because it's literally in every other math class you're ever going to take. Even when you get to like calculus, literally the first step is calculus and everything after that is Algebra 1. Do you know your laws of exponents? Are you able to simplify? Can you combine like terms properly? Can you know what I mean? Like, so that's the part we need to work on. Okay, so Algebra 1 is going to be the part that's going to mess us up. All right, but it's okay. We'll just keep practicing. All right, cool. Example 4. So I'm assuming y'all can set this up. Go on ahead and set it up. I'm gonna give you like 30 seconds and then you can see how I set it up just to make sure that we're okay with that. So go on ahead and set this up while I highlight and do all my, usual stuff. Okay, I'll probably set it up and then I'll probably let y'all go to lunch. So we won't finish example 4, we'll just get it started. Okay, so f divided by g of x, right? So that basically means we want f of x divided by g of x, right? That's what we're saying here. So then your setup should be f of x is on the top, so we should have 4x to the power of 5 over 4. Oops. 5 over 4 over g of x, which is 2x to the power of 1/2. So that's the easy part. That's today's lesson, being able to identify that and do this. Everything from here on after is literally just algebra 1, right? So we're dividing bases. So this is going to be laws of exponents. How do I know it's laws of exponents? Because I'm dividing and I have the same base, which is x, on the top and bottom. So when we're dividing bases, what are we going to do with exponents? Subtract. Yeah. So anytime, so right here, we see quotient law, which means we're going to subtract exponents. So remember, you always do top minus bottom. So 5/4 minus the bottom, which is 1/2. Okay, I'm gonna stop there because it's about to be lunchtime, and then we'll finish example 4 when we come back. Let me. Okay, so I will see y'all. Oh, I wanted to pause the record. All right, there we go. So we left off in subtracting our exponents, which is 5/4 minus 1/2. When we're subtracting, they have to have the same denominator. So we're really going to have 5/4 minus, what is it, 2/4, right? 2/4 is the same as 1/2. So 5 minus 2 is 3/4. And then we have 4 divided by 2, which we know 4 divided by 2 is just 2. So we're going to have x to the power of 3/4. And the reason that goes in the numerator and not the denominator is because 3/4 came out positive, right? So if it's already positive, you just leave it at the top. If it would have been negative, then it would have gone to the bottom to get rid of the negative exponent. And again, all of these things that I'm saying is just laws of exponents, and practicing and getting better at those. Okay, now we talked about the different ways you can write this, right? So this could be your answer, or you can also write it as 2. So this would be the 4th root of x to the power of 3, right? That's the other way you could decide to write it. Okay. Then the last part is evaluate the quotient when x equals 16, right? So what we want is f divided by g when x is 16. So we already know what f divided by g is, right? It's these two things that we said could be our answer, just depending on how far you want to simplify. So all you have to do is substitute 16 inside. So then we would have 2, and I'm going to use the radical form, 16 to the power of 3, right? So then this requires us to be able to simplify. So we know that this is the same as 2 to the 4th root of 16 times 16 times 16, right? And we know 16 is really 4 times 4, 4 times 4, and this last one is 4 times 4. I want groups of 4, so you can notice that you already have a group of 4. So we're going to go on ahead and take that out. And we have 2 4s left over, but these 4s can also be simplified to 2 times 2 times 2 times 2. We now have a group of 2 that we can take out. So we're going to have 2, which is the one we already have, times the group of 4 we took out, times the group of 2 we took out. What's left inside? Nothing. So 2 times 4 is 8, and 8 times 2 is 16. So we know that when we divide the function f and g and substitute 16 in it, we get 16 out of it. Okay. Now, for example 5, The table shows the outputs of two functions, right? So we have f of x, which is right here, and then we have g of x. Use the table to evaluate the following. So here we want f plus g when x is 3, right? That's how we could say that. So for part A, we want f plus g when x is 3. So you can also write this as f of 3 plus g of 3, right? Instead of x, we have a 3. So do we know what f of 3 is? Look at our table and type it in the chat. What is f of 3? Type it in the chat. I should have about 19 responses. Okay. So f of 3, here's f, oops, and 3 is x. So then we know that f of 3 is 10. Plus, what would g of 3 be? Type it in the chat. Good. Negative. Ooh, ¿qué hice? My bad. There we go. Negative 31, right? So when x is 3, f of 3 is 10 and g of 3 is negative 31. So all you do is simplify. 10 plus negative 31 is negative 21. That would be your answer. So f plus g of 3 is negative 21. Ta-da, you're done. So what would b be? I'm going to give you 1 minute to do B, and then you're going to type your answer in the chat. 1 minute. Let me see. Go. Okay, so this is the same as saying f of 1 minus g of 1. So here's where x is 1. So I'm going to be using f of 1 is negative 4 minus g of 1, which is negative 3. This is the simplifying part. So this is where a few of you messed up. A minus in the negative is always going to be a plus. So bring down the 3, negative 4 plus 3 is negative 1. Be careful with that. So those of you that got negative 7, hopefully you see your mistake. So if you got negative 7, it's because you did negative 4 plus negative 3. Okay, C and D. Go on ahead and do those as well. I'll give you a minute and a half for both of them. So go on ahead and do those. A minute and a few seconds. Okay, so for C, this is really saying we want f of 2 times g of 2. So f of 2 is 0 times g of 2, which is negative 13. Well, anything times 0 is just 0. So 0 would have been your answer for C. And then for D, we want f of 0 divided by g of 0. F of 0 is negative 2 divided by g of 0, which is negative 1. Negative in a negative is always a positive, and then 2 divided by 1 is 2. So your answer is just 2. Okay. Example 6. Use the graph to evaluate the following. Okay. Same thing, but now instead of a table, you have a graph. So for A, we have f of 1. Okay, so on this graph, you can see that my blue line is f of x, and then my red line is my g of x. So f of 1, remember, inside my parentheses is the x value, right? So I want to go find where x is 1 for f. 1 is right here. So I'm going to go to the blue, which is right here, and that y value is 1 plus g of 4. So I'm going to go to where x is 4, and I want the y value of g, which is right here, which is 4. So 1 plus 4 is 5. Ta-da, we're done. Okay, go try B on your own. Or actually go do B, C, and D. See how that goes. I'll give y'all 2 minutes and then we'll go over it together. Type them in the chat as you're finding them. Okay, so for B, all you're doing f of 0. So you want to go to the function f. When x is 0, what is y? So that's what that means, right? So f of 0 should have been, f of 0 should have been 1 minus g of negative 1. So g at negative 1, g was 4. So 1 minus 4 is negative 3. So when you subtract f of 0 and g of negative 1, you should have gotten negative 3. For C, f of 4, so f of 4 was 4, and then g of negative 1 was also, no, wait, g of negative 1 is over here, which is 4. F of 4, oh, haha, no wonder. Okay, just kidding. All right, that should have been 5, my bad. So f of 4 is right here, which was blue, right, which is 5. And then g of negative 1 is 4, so 5 times 4 is 20. And then the last one, D, f of 3. So f of 3 is 4 divided by g of 2, which is red. So g of 2 is also 4. And 4 divided by 4 is 1. Oh, we still have more to go. Okay, so yes, thank you. Okay. So that was function operations, right? So adding, subtracting, multiplying, dividing, okay? Now we're gonna be looking at composite functions, okay? So if you think of composite, that word should have first came up maybe like in elementary or something, right? Which basically means putting two things together, like intertwining them, right? So a composite function is a combination of two functions. So you're gonna notice that right here, right? So this first part that we're looking at is what I just highlighted green. There we go. So that right there is f of g of x, okay? It sounds kind of weird and like, I don't know, it sounds weird, right? So just how you would say f of x, right? That's how we say that, right? F of x, okay? Well, now we're saying f of, well, what's inside of it? G of x. So f of g of x. So, you know, y'all probably never watch Friends, but did you ever watch that one episode of Friends and they're like, they don't know, but we know they know, we know they know, we know. You know what I'm know? You know what I'm know? Anyway, okay, so, okay. So another way to write that is this second part right here, right? There's like a little open circle in between that. Okay, so the way I think of it is that you have f, which is what you're starting with. And then inside, you're gonna fill it in with g of x. So these two right here mean the same thing, okay? They're the same. Sometimes you'll see it written as the first one. Sometimes you'll see it written as the second one. You say them a little different, but they mean the same thing. So if you have that F and then the little open dot, a G, you're really saying it F composed with G of X. Okay. So right here, you can see that this is equal to that, right? So whatever comes first is written on the outside, whatever comes second goes inside. All right, so example 1, if f of x equals 2x plus 5 and g of x equals x minus 3, it's asking us to find f of g of x and g of f of x. Yes, those are two separate things. They're two different things. And you can see that f is composed with g of x on the first one. But for the second one, it's g composed of f of x, okay? All right, there's two ways you can kind of look at this. And when I was doing it, I was trying to tell myself which way would make more sense and which way sounds easier. I don't remember what I told myself. Okay, well, first of all, let's break it down. We have g composed of f of x, right? So that means that because I see that g first, that means that the g is going to be on the outside, oops, right? So g and that f is on the inside. So you're gonna grab what's on the outside, right? So what do we see on the outside? Which function? G. So I'm gonna grab that function and I'm gonna put whatever is inside of it, which is f. Okay, so here's what I mean. So you see how this g is on the outside, right? So we have x minus 3. So I'm gonna write x minus 3 because that's what g is. So that's the first thing I did, g. So I wrote down what g is. G is x minus 3. So what am I going to put inside of this function? Yeah. So does everyone see how this inside is f of x, right? So right here, instead of putting an x, I'm gonna grab the function f and I'm gonna put it there. That's it. Okay? So instead of this x, I see f of x. So I'm gonna grab f of x and I'm gonna substitute it inside 2x plus 5. And then I'm gonna grab the rest of g and then just bring it down. So you're like doing a substitution inside of a substitution. I know this is a little confusing, so give me a minute. Okay, so do you see how it has the g on the outside? Right? Okay, so g is x minus 3, which is what I wrote first, right? So this is g of x. It's on the outside, right? So I wrote that first. And inside of that function, I'm gonna put what's on the inside, which is instead of a number, right? You're used to seeing a number, right? If I had a 3 there, wouldn't you just plug in the 3 and be done? But we don't have a number. Instead, I'm telling you to plug in a whole nother function. It just looks weird, okay? And then all we have to do now is simplify. So we're gonna have, there's nothing to distribute, so 2x plus 5 minus 3, combine like terms, so 2x plus 2 is what you would end up with there. So we're gonna do this again, okay? So we have f composed with g of x, right? Which basically means whatever comes first is what you're gonna start with, right? So another way of writing this, right, it would be f and then g of x on the inside. So what's the first thing I'm going to grab? F, right? So you're gonna grab f, which is 2x plus 5, because that's on the outside, right? So I'm grabbing 2x plus 5. Or hold on, I'm explaining it 2 different ways. So we're gonna grab 2x plus 5, right? And then on the inside, we have g of x. Well, what is g of x? G of x is x minus 3. So instead of an x, I'm gonna put x minus 3. And then just bring down the 2 and then the plus 5. And then simplify. 2 times x is 2x 2 times -3 is -6. Bring down your +5. Combine like terms, 2x minus 1. Okay, here's another way you can think about it, because I understand that everyone's brains works different, right? So instead of starting from the outside, we're going to start from the inside, okay? Because it's technically the same thing. So looking at this, right? So let me delete that. So it's still f of g of x, right? That doesn't change. So instead of starting from the outside, you can start from the inside. So inside, what do I see there? G of x, right? Well, what's g of x? G of x is x minus 3. Put my parentheses in my f. So this should look a little bit more familiar, right? We want f of x minus 3. So what are you going to do? You're going to grab f, which is 2x plus 5. And everywhere you see an x, you're just going to replace what you see on the inside. So 2 times x minus 3 plus 5. You're going to see you end up with the same thing. 2x times 2 times -3, so 2x minus 6 plus 5. Combine like terms, you still end up with 2x minus 1. Did the second way make more sense? Which one did we prefer? Or are we still just confused? Okay, 1, 3, 5, go in the chat. 1, totally lost. 3, you're okay. 5, the host. 5, you got it. Okay, so now what I want you to do is tell me which way made more sense. The first way, or which one's the one that clicked for you, that you're like, oh, okay, that one made it seem not as bad. The first way or the second way? Okay, well, we got a combination of both. See, that's why I did it both ways. Okay, so example 2. We're gonna do it, I guess I can do it both ways just so that y'all have, this is the last example, right? Yeah. Okay, so we'll, yeah, we have time to do it both ways. Okay. So we have f of x and we have g of x. So now we're going to define f composed of g of 3. Okay, which we already know this is the same as saying f is on the outside because it comes first. On the inside, we're going to have g of 3. Now, you can go on ahead and plug the number in, right, instead of x. Or you can do what we did in example 1, where you're going to find the equation first and then plug in the number. Whatever you want, it's up to you. Let me see what I did earlier. I found it first. Okay. All right. So the first thing I'm going to do is find f composed of g of x. Okay. So we have our f of x and we have our g of x. So way 1. Okay. So we know we have f is on the outside. So I'm going to write f, which is 5 minus 3x. And then on the inside, we want g. So instead of x, I'm going to plug in 5 minus 3 times whatever g of x is, which is x squared plus 4. Way 2 is grabbing, right? Well, what is g of x? Because it's inside my parentheses. Well, that's x squared plus 4, right? So then now all I have to do is grab f, which is 5 minus 3, and then instead of x, just substitute what I see in here, which is x squared plus 4. You can see that you literally end up with the same thing. And then now all you have to do is simplify. So it's whatever makes more sense to you. If you want to start outside, start outside. If you want to go from the inside out, go from the inside out. It doesn't matter. You should end up with the same thing. Okay, so simplifying, right? We're gonna end up with, no matter which one you do, 5 minus 3x squared minus 12. Combine like terms, so 5 and negative 12 is gonna give you negative 3x squared minus 7. So I know that f of g of x is equal to negative 3x squared minus 7. So I'm going to grab this and I'm going to find f of g of 3. So all I have to do is substitute the 3 in. So we're going to have negative 3 times 3 squared minus 7. When you do the math, you end up with negative 34. I mean, there's several ways you can think of this, right? You could have also just gone ahead and found g of 3. So if you have f of g of 3, right? Well, what's g of 3? I know where g is. G is right here. So 3 squared is 9. 9 plus 4 is 13, right? And then f of 13, plug in 13. 13 times negative 3. So 5 minus 3 times 13 would have also been negative 34. So you would have gotten the same thing no matter what. Yeah. Okay, so your assignment is over this, obviously, composition of functions, and then just what did we just do? Function operation. Okay. So you have your notebook check. Go on ahead and do that now. And then you also have your quizzes assignment. Both of them are in your modules. And your outline for lesson 6.6 is also already linked on there. Okay. So 6566, after lesson 6.6, you're going to have an exam. So your exam is only going to be over these two lessons, 6.5 and 6.6. Just so y'all know. Okay, so take the rest of the 30 minutes to get your quizzes done, submit your notes. And if you are missing 6.1, 6.2, 6.3, or 6.4, get that done. All of the quizzes on the late assignments work. And notebook checks, get that done before I get it in the grade book so that you don't get points taken off. Monday. You've already turned in all your notes, so then you need to do all the late assignments. 6.1, 6.2, 6.3, 6.4. Boy.
Which note?
6.1. Yeah. Okay, any questions, comments, or concerns? Let me pause my recording because I'm done with that.
Oh,
Monday? Hold on. Huh?
6.5.
Yes. What? You do? I was doing graders. Okay, so for these next 30 minutes, y'all do y'all's assignments. If you still haven't done telepath, make sure you get that done. And I'm gonna keep grading y'all's notebook because that's what I was doing anyway. Okay. All right, I'm gonna play some music. So yeah, go do your work. Oh, I thought I stopped recording. Oops.